There were many scientists who contributed to the development of the periodic table, but the one scientist that is given the most credit is known as Mendeleev, who was a Russian chemist. And what he did is he ordered the known elements by atomic mass, and he happened to see a repeating pattern of chemical and physical properties. And so he came up with this idea of what he called a periodic law. When the elements were arranged in order of increasing relative mass, certain sets of properties seem to occur periodically. And he used this pattern to predict the properties pretty closely, actually, of, at the time, undiscovered elements. Now, there were a few cases where the mass did not fit the properties, and so he rearranged a couple of these elements according to the properties, and that was tellurium and iodine. So here's a little sample of what he worked with. He noticed that lithium and sodium reacted the exact same way with hydrogen. Beryllium and magnesium reacted the same way with hydrogen. So did boron and aluminum, carbon and silicon, nitrogen, phosphorus, oxygen, sulfur, chlorine, and fluorine. He also noticed similar physical properties between these elements. And if you notice on our current modern-day periodic table, these elements are right above one another, and that's important. We're going to look now at what's known as periodicity. And what periodicity is the ability to predict properties based on placement on the periodic table. The easiest way to classify the elements on the periodic table is to classify them as a metal, a metalloid, or a nonmetal. Metals are shaded here as blue, and you can clearly see that they make up most of the known elements. They're on the left-hand side, whereas nonmetals are on the right-hand side, except for hydrogen. We'll learn later why hydrogen is over here. And then there is a group of 7 elements known as the metalloids, which occur right on the boundary between the metals and the nonmetals. Let's take a look now at some of the properties of the elements. And when we're looking at these properties, we are looking at the properties of the elements, not the elements combined in a compound. Metals are solids at room temperature except for mercury. They have reflective surfaces, which we see as shiny. It's also known as luster. They easily conduct heat and electricity, and they are malleable and ductile, meaning they can be easily dented or shaped or pulled into wires. These are some of the physical properties of metals. The chemical property of metals is that they lose electrons and form what is known as cations. We'll learn about that in the end of this chapter. About 75% of the elements are metals, and their placement is in the lower left-hand side of the periodic table. Nonmetals, this portion of the periodic table, are found in all 3 states, solid, liquid, and gas. Although, like the metals, only one is in the liquid state at room temperature, and that's bromine. Unlike metals, nonmetals are poor conductors of heat and electricity. And unlike metals, the nonmetal solids are brittle, meaning that they would break into pieces rather than being dented or shapeable. And unlike metals, they gain electrons, and they either become anions, which we'll learn about later, or they share electrons. So nonmetals have 2 options when it comes to electrons. They can either gain or share. Metals can only lose. They are found in the upper right-hand corner of the periodic table, except for hydrogen, which is on the left. And then let's take a look at metalloids. Metalloids are on this staircase, and they show properties like that of metals and nonmetals. For example, metals conduct electricity, nonmetals do not. Metalloids do what's known as semiconduct. They don't conduct electricity as well as metals do, but they do conduct electricity through a different mechanism. So let's look at some of the properties of silicon. Like metals, it's shiny and conduct electricity, although it is just semiconducting. And like nonmetals, it does not conduct heat well, and in the solid form, it is brittle. All metalloids are solid at room temperature, like metals. So they have properties like metals and nonmetals, and so we give them their own special group. So pause the slide and see if you can find these 5 different elements on the periodic table and identify them either as a metal, nonmetal, or a metalloid. So here's xenon, and it's on the far right-hand corner of the periodic table, so it's a nonmetal. Tungsten, with the symbol of W, is on the left-hand side of the periodic table, so it's a metal. Bromine is on the right-hand side, so it's a nonmetal. And arsenic is right on that staircase, so we'll call that MD for metalloid. Cerium was way below down in one of the columns, the rows at the bottom in the lanthanide section, and that is a metal. Elements with similar chemical and physical properties are in the same column, except for hydrogen. The columns are known as groups or families, and rows are known as periods. So let's look at the periodic table. This would be the first period here, the second period, third period, fourth period, fifth period, sixth period, seventh period. And where do these two guys come in? Well, they're actually part of the sixth and seventh period, and we can tell that by looking at the atomic number. Here's number 57, and next to it is 72. Where are all the others? Well, they're down here. 58 to 71 is here. Here's 89, here's 104, 90 to 103 are down here. So there are 7 periods in the periodic table, and these two down here are part of the 6th and the 7th, and we'll learn later why. Now let's look at some of the names that you need to be familiar with. This family here, the first family on the left-hand side, not including hydrogen, are known as the alkali metals. The next family are known as alkaline earth. This block here of metals are known as transition metals. These metals over here are known as main group metals. These metals here, this top row, are the lanthanides, and this bottom row are known as the actinides. And that name comes from this element here, the lanthanum, and actinium. These are the elements right before the rows begin down there. 2 other families you should know are the noble gases and the halogens. These do have other names, but they're a little confusing and they're not always used that frequently. So if we need to refer to these families here, we will typically use the numbers and letters that you find above on your periodic table. So let's look at some of the properties of our first family, the alkali metal. Notice hydrogen is not here. Alkali metals, also known as group 1A, are soft, low melting point, low density metals. They float on water and they are very, very reactive. We never find these in the elemental state in nature, ever. We find them in compounds. So sodium is commonly found, but never as an element with the same number of protons and electrons. It's found in a compound. These metals react with water, so giving off so much heat that flame is also often formed, and they form what's known as a basic or alkaline solution, which is why they're known as alkali metals. The next group over are known as alkaline earth. And alkaline earth have higher melting points and they're a little denser than the alkali metals. They do sink in water. They are reactive, but not as reactive as the alkali metals. They will bubble in water, but they won't catch on fire generally. The oxides, like the alkalis, are basic, which is why we have the name alkaline earth. And as we go down, they become more reactive. Beryllium at the very top will not react with water. Magnesium will react with water if it's in the form of steam. And calcium, strontium, barium will all react in cold water. And here's some calcium right here reacting in cold water and forming hydrogen bubbles. The halogens are the second group from the right-hand side. These are also very reactive elements, but these are nonmetals. They exist in nature as diatomic molecules, F2, Cl2, Br2, and I2. Fluorine and chlorine are gases. Bromine is a liquid, and iodine is a solid. And astatine is radioactive, so even though it's part of the family, we don't do a lot of chemistry with it. The noble gases are the last family on the right on the periodic table, also known as group 8A. They are all gases at room temperature, which means they have very low melting and boiling points. They are extremely unreactive. It takes a lot of work to get these two guys to react. In fact, someone won the Nobel Prize for getting these to react with fluorine and oxygen, which are very, very reactive in and of themselves. Very difficult to remove an electron or give an electron to. So that's where the chemistry occurs, when you can move electrons around, and these guys are not interested. So they're called noble because they don't want to interact with any of the other chemicals.